Is there room for one more? Says the computer. In this video, we're going to take a look at calculating the quantity of how many valid IP addresses are available for each of our subnets. Here's the opt-out questions for this video. If you can answer all three of these correctly and comfortably, please join me in the next video. Otherwise, for everybody else, we're going to have a great time as we determine the exact number of hosts that can be fit into a given subnet. Let's begin. I'd like you to imagine that you and I have just finished a custom subnetting plan for this network topology. And we're pretty darn happy about it too, because here's what we did. We identified how many subnets we'd have to create. We recognized how many bits we'd have to steal from host address space to create those subnets. We identified the new subnets. We moved the mask over to represent the new mask for the entire network. And not only did we identify the subnets, we also identified the valid IP address host range within each of those subnets. Now, what we haven't yet done is we haven't identified how many hosts will fit in a given subnet. Now, I suppose we could do this. We could say, well, the first host is X and the last host is Y, and we could manually count between X and Y inclusively to figure out how many individual IP addresses are there in that subnet. But there's a much better way just to calculate raw quantity, and that process is this. Number one, we're going to identify the number of host bits available. So in our topology, let's say we ended up with a /27 mask. And for this question, it doesn't even matter where we started. It's just a matter of where we ended. So we have a /27-bit mask, and my question is, how many host bits are available that the mask didn't take and allocate for the network address? So if you're thinking, well, Keith, let me think about this. We have a 32-bit IP version 4 address. We are using 27 of those bits for the mask. That would leave exactly 5 bits available for host addressing if we're using this mask. And that is absolutely correct. So that's our first step for calculating the quantity of PCs, printers, router interfaces, switch IP addresses that may be in that subnet. That's the very first step, is to identify how many host bits we have to play with for that subnet. And here the answer is 5. The second thing we're going to do is we are going to use the finger game. And again, our fingers, our digits, are representing the actual bits. In this case, however, our fingers, our digits, are representing the 5 available host bits. So we're going to stick our thumb up in the air with that big old 2 on it, and we're going to say 2. And then we'll bring up our second digit and say 4, the third digit and say 8, the fourth digit and say 16, and that fifth, and that's our goal, by the way, that fifth digit in the air, and we'll say 32, and that, my friends, is very close, not exactly, but close to the number of hosts, valid host IP addresses in that given subnet. Now you might be saying, okay, Keith, what do you mean it's close? It's either, this is math, it either works or it doesn't work. Well, it is true that if we have 5 bits, we have 32 different combinations. However, not all of those are valid host addresses. For example, with a /27, we know that we're stealing the first, second, and third bits out of that 4th octet. So right here is the 24-bit boundary. There's 25, 26, 27. So here's our new boundary line, if you will, between the network and host bits. Network on the left of the blue line, host bits on the right. So here's our 5 host bits right here that the mask didn't take. So for a /27, if we wanted to know the subnets, here's the block size right there, 32. We know the subnets are 0, 32, 64, 96, and so forth. And the first 3 numbers we really don't care about because they are going to be the same on every single one of our subnets. It's this last octet where we're slicing and dicing. And the new mask, of course, would be /27 for each of those. So let's pick an example here. Let's say that this subnet 2 is going to be subnet 64. So this subnet right there. So what is the first valid host? Well, Keith, the first valid host is the subnet, as we learned in our course, and it's the subnet plus 1 more. So the first valid host would be 65. Excellent. So that's the first valid host. What's the last valid host? Well, the last valid host, as we've learned, is the next subnet minus 2. So if the next subnet is 96, the last valid host on this 64 subnet would be 94. And that is our range. And the broadcast address, I'll put B for broadcast right here, would be 95. So the reason I point that out is that this 32 is all the possible combinations we can get with 5 bits. However, we cannot, I repeat, we cannot assign the actual subnet address to a host interface like a router interface or a printer or a PC. It won't allow it. It'll say, hey, this is the actual subnet. There's no bits that are on in the host portion. It's sort of like me saying I live on like 123 Elm Street, and you ask me for my address. It'd be like saying I live on Elm Street. Well, what host or what house are you on Elm Street? No, I just live on Elm Street. It's not enough information. We have to have at least 1 bit of the host portion that is on for it to be a valid IP address that we can assign to an interface. So what that means is we have 32 minus 1 for the subnet, which we cannot assign to an individual interface. And the other one that we cannot assign to an interface is the broadcast address for that same subnet. So we're also going to do minus 1 based on the broadcast address. And for that reason, when we calculate the number of hosts available on a subnet, we're going to play the finger game, but when we get our result, we're going to go ahead and subtract 2. And that's because we cannot use the subnet itself, that subnet address, nor the broadcast as a valid IP address on an interface. So I'd like to do one more example with you on that. And that example is this. Let's say we have a /30. So we have a /30 mask. My question for you is, how many valid hosts could we put on a subnet that had a /30? Now at this point, I want you to go through this process. I'd also like you to take a moment right now and pause the screen and write down these 3 steps regarding how to exactly calculate the quantity of hosts on a subnet. So go ahead and pause me, write these 3 steps down, do the math for a /30, and then resume me and we'll compare notes. All right, how'd you do? Well, our first step on this is to count the number of host bits available. Well, 30 bits are being used for the network. That leaves only 2 bits for host addressing. So the answer to that is 2. We're going to use the finger game with our digits representing host bits. So we'll put 2 fingers up in the air and we count verbally to 4. That's our result. And then we subtract 2 because we can't use the actual subnet or broadcast address on an actual interface. So minus 2 equals a total of 2 possible IP addresses for valid hosts on a /30 network. So you got it, my friend. That's exactly how we can calculate the total number of hosts that will fit as far as valid IP host addresses on a subnetwork. Our exercises for this video are simple as to make sure that you have practiced along with me in this video regarding calculating the actual number of hosts that would fit on a given subnet based on the mask. And secondly, go ahead and take a moment and check out the opt-out questions at the beginning of this video just to make sure that you are now comfortable and capable of answering those questions. I've had a great time. I appreciate you joining me. I hope this has been informative for you, and I'd like to thank you for viewing.